In lesson 3.3, we're going to spend a little more time looking at what length of streak makes a team streaky or not streaky. And you may recall from earlier lessons that when we run a test for streaks, our hypotheses will always take this format. The null hypothesis is always that the outcomes of the games are independent, and the alternative is that the team is streaky. In order for a team to be streaky, we need to reject the null hypothesis. And to do that, we know that our p-value has to be small, which means it has to be less than 5%. For our example today, we're going to look at a team that had 24 games in their season, and they finished with an overall record of 16-8. We're going to examine different scenarios of the season where the number of successes and failures are mixed around so that they have different lengths of streaks, and we're going to see when the team becomes streaky versus not streaky. And these are all for a season where they finish 16-8. So the same number of overall wins and losses, just different lengths of streaks. So we're going to organize all that in this chart. Notice in scenario number 1, their longest streak occurs right here where they have 5 successes in a row. So they had 24 total games, 16 total successes, but the longest streak in this case was 5. Now, to determine the p-value and whether this would make them a streaky team or not, we're going to look at the dot plot. With a test statistic of 5, that means we would need to count all of the dots that are at 5 or above that. And there are 100 dots total in this simulation. So 77 dots out of 100, or 77%, would be our p-value. And this p-value is very large. So we would fail to reject the null hypothesis, which means we do not have evidence that they are streaky, or in other words, we can say no, they do not have the hot hand. In scenario number 2, here our longest streak occurs toward the beginning of the season, and here they have 6 successes in a row. Again, we go back to the dot plot. This time we're going to count the number of dots that are at 6 or above. And in this case, we had 54 dots out of 100, still too short of a streak and too large of a p-value to say that the team has the hot hand. In scenario number 3, their longest streak is 7 in a row. In the dot plot, if we count up all the dots that are at 7 and above, we have 30 dots this time. 30% is still too large of a p-value to reject the null hypothesis. So we would say no, they do not have the hot hand. In scenario number 4, we're looking at 8 successes in a row. From the dot plot, we can see that there are a total of 20 dots at 8 or above. Still, we would reach the same conclusion, fail to reject the null hypothesis, so they do not have the hot hand. Now, scenario number 5, we have 9 successes in a row right in the middle of the season. Now we're getting smaller and smaller p-values. Notice as we work our way to the right with longer and longer streaks. If we count the dots at 9 and above, we have a p-value of 9%. Still, same conclusion. No, they do not have the hot hand. Now in scenario number 6, we're at a longest streak of 10 in a row, and that occurs toward the beginning of the season. If we count the number of dots that are at 10 and above, notice we only have 4 here, 4 out of 100 possible simulations. So in this case, our p-value would be 4%. And at this point, we've reached the threshold where our p-value is below the cutoff of 5%. Therefore, this is the first point in this chart where we would reject our null hypothesis. And that would allow us to say, yes, they actually do have a hot hand. And from this point on, our p-values are just going to continue to get smaller and smaller. So in scenario number 7, they have a streak of 11. From the dot plot, we can see that our p-value would be 3%. We would reject. And then with a streak of 12, our p-value would be only 1%, so we would continue to reject the null hypothesis. Now, we might end up with longer streaks. It's possible, for example, that they could have a streak of 13 in a row, or 14, or up to 16 in a row. And obviously, those would all be the same results. The p-value just continues to get smaller and smaller, and we would reject the null hypothesis in each of those cases. Now, the next question in your notes asks, at what streak length is the analysis changed from not having a hot hand to having a hot hand? And that was 10. So 10 is the shortest possible streak that the team could have and still be considered streaky. Anything longer than that would, of course, also consider them streaky. Please do homework 3.3 in your assignment packet.